Well, student, today I will tell you about valence bond theory in coordinate compound. In this video, I will tell you how to determine the hybridization of the central metal atom in coordinate compound. Second, what is meant by inner orbital complex and outer orbital complex. And the third thing is how to calculate the spin-only magnetic moment of a coordinate compound. Let's start with our topic valence bond theory in coordination compound. We all know that coordination compound are formed by transition metal, and so we need to memorize the electronic configuration of the transition metal from scandium to zinc. For example, iron. The atomic number of iron is 26. Fe, the atomic number is 26. Its electronic configuration is argon 3d6 4s2. So its electronic configuration is argon 3d6 4s2. Now the valence shell is N is equal to 4, that is the fourth shell is the valence shell. Now the fourth shell contains ns orbital, that is 4s orbital, 4p orbital and 4d orbital. This p and d orbital are empty. Now, according to valence bond theory, the central metal atom under the influence of ligand can utilize its n-1d, that is 3d, ns, that is 4s, np, that is 4p orbital to form a set of hybrid orbital, or it can use ns, that is 4s, np, that is 4p, nd, that is 4d to form a set of hybrid orbital. So what the metal atom can do? The metal atom under the influence of ligand can use n-1d, ns, np to form a set of hybrid orbital, and it can also use ns, np and nd orbital to form a set of hybrid orbital which has equivalent energy and definite geometry. For example, tetrahedral, octahedral and square planar. The hybridization of the central metal atom depends on the coordination number of the central metal atom in the coordination complex. So, we will first see the correlation between coordination number and hybridization. Coordination number, hybridization, shape and examples. Now, the coordination number 4, the hybridization can be sp3 or the hybridization can be dsp2. So when the coordination number is 4, it can be sp3, it can be dsp2. Now if it is sp3, the structure is tetrahedral, often written as TD. When the coordination number 4 and the hybridization is dsp2, the shape is square planar. Example, nickel tetrachloride 2 minus, nickel tetracyanide 2 minus. The next coordination number is 6. When the coordination number is 6, the hybridization can be D2 sp3 or it can be sp3 D2. Now when both the coordination number, the shape of the molecule is octahedral, that is OCT. For example, the first type is CONH3 whole 6 3 plus ion, and the second type is COF6 3 minus ion. That means in case of CONH3 3 plus ion, the hybridization is D2sp3. And in case of COF6 3 minus ion, the hybridization is sp3d2. Now D2sp3 means it is using the inner D, that is 3D, and here when it is sp3d2, it is using the outer D, that is 4D. Since it is using inner D, so this type of complex we call it inner orbital complex. Inner orbital complex. That is, this compound is inner orbital complex. When the outer D, that is 4D, is used, this is called outer orbital complex. Okay, so we'll take a specific example and we'll see how the hybridization can be correlated with the magnetic moment value. Valence bond theory cannot predict the shape or structure of the coordinate compound unless until the magnetic moment of the complex is known. That is, valence bond theory can only predict the shape of the compound if the magnetic moment data is known. For example, CONH3 whole 6 3 plus ion, COF6 3 minus ion. This compound is diamagnetic and this compound is paramagnetic. Now diamagnetic means there is no unpaired electron, and paramagnetic means there are unpaired electrons in the compound. So let's start with the first compound, CONH3 whole 6 3 plus ion. Now the atomic number of cobalt is 27. So its electronic configuration becomes argon 3d7 4s2. It's very easy to memorize the electronic configuration. 27 means D7, 26 means D6, 28 means D8, like this. 29, there is one exception, so it is D10 4s1 for copper. Again 30, D10 4s2. Now in this complex, the cobalt is in +3 oxidation state. So we have to write down the electronic configuration of cobalt 3 plus. Cobalt 3 plus, it is 3d6 4s0. 3d6 4s0. So this is 3d orbital which contain 1, 2, 3, 4, 5, 6. 4s is empty, 4p is empty. Now there are 6 ligand, and so we need 6 orbital because each ligand will donate a electron pair, that is 2 electron, and a orbital can accommodate 2 electron, a maximum of 2 electron. Now since it is written that the complex is diamagnetic, that means the compound will not have any unpaired electron. Here we can see there are 4 unpaired electrons. So the next step, what we have to do, we have to pair up the unpaired electron. 1, 2, 3, 4, 5, 6. Now we can see we are using these 2 orbital 1, 2, 3, 4, 5, 6. So we are having 6 orbital and there are 6 ligand. So 6 ligand will donate electron into 6 empty orbital, and those empty orbitals are D2, 1s and 3p. So the hybridization becomes D2sp3. since the 3D orbital is used and not 4D. So this type of complex is called inner orbital complex. They are also called spin paired complex, since all the spin has been paired up. They are also called spin paired complex, or they are also called low spin complex. Low spin complex. Next we will discuss COF6 3 minus. Now COF6 3 minus, the electronic configuration of cobalt is same. Now the oxidation state of cobalt here. So if you don't know the oxidation state of cobalt, the very easy way of determining the oxidation state is take the oxidation state of the cobalt as X plus how many fluorine atom are there? 6 fluorine atom. Fluorine atom, it is -1 oxidation state, -1, and the overall charge is -3. So X comes out to be +3. So that means cobalt 3 plus, and the cobalt 3 plus electronic configuration is argon 3d6 4s0. So again we can write three d 6 1 2 3 3 4 5 6. Actually we should write 1 2 3 4 5 then 6. 4s which is empty, 4p which is empty, 4d again empty. Now it is written the compound is paramagnetic. That means the compound contains unpaired electron. So we will not pair up this electron, but at the same time we need 6 orbital, because there are 6 ligands which will donate 6 pair of electron, and 6 pair of electron can be accommodated in 6 orbital. So we will start from this orbital, this empty orbital, 1 2 3 4 5 6. So up to this. So we are getting S 3p, that is sp3, and 2d, that is d2. Now since we are using 4d orbital, so this type of complex are called outer orbital complex, or since the spin is free, they are not paired up, it is also called spin free complex. Since they are of high spin, means all the spin are positive spin, so they will add up to give high spin, hence they are called high spin complex. So all these 3 names are used: outer orbital complex, spin free complex, or high spin complex. So whenever it is written outer orbital complex, that means it is a spin free or high spin complex. Whenever it is written inner orbital complex, that means it is a low spin complex or spin paired complex. Often in CBSE the question arises that nickel tetrachloride is paramagnetic, whereas nickel tetracyanide is diamagnetic. NiCl4 2 minus NiCN4 2 minus. Now we have to know the atomic number of nickel, that is 28. So its electronic configuration is argon 3d8 4s2. Now in this complex nickel is in +2 state. How to calculate? X plus 4 chlorine each having -1 charge, and that is equal to -2, the overall charge of the complex, and so X will come out as +2. So nickel is in +2 oxidation state. Now +2, the electronic configuration is argon 3d8 4s0. This is 3d8, 1, 2, 3, 4, 5, 6, 7, 8 and 4s0. Now since nickel tetrachloride is paramagnetic, it is paramagnetic, and this one is diamagnetic. Now since it is paramagnetic, so it should contain unpaired electron. Now it has 2 unpaired electrons, so we will not pair up this unpaired electron. At the same time, we need 4 orbital to accommodate 4 electron pair donated from chlorine, 4 chlorine. So here we have 4s, 4p. So total of 4 orbital, so it is sp3. Hence the hybridization of nickel tetrachloride is sp3 and the geometry of the molecule is tetrahedral. Now in case of nickel tetracyanide, it is written the compound is diamagnetic. Again here nickel is in +2 state. +2 means argon 3d8 4s0. So again we can write 1, 2, 3, 4, 5, 6, 7, 8. Now since it is diamagnetic, there should not be any unpaired electron, so we will pair up the electron. How we will pair up? We will put this electron in this orbital. So 1, 2, 3, 4, 5, 6, 7, 8. Now we are having 4 orbital from this 3d, and we'll stop here. So we are getting dsp2. So the hybridization of nickel tetracyanide is dsp2 and the shape of the molecule is square planar. Next I will discuss how to calculate spin-only magnetic moment. Mu spin-only is equal to root over n into n plus 2, where n is number of unpaired electron. Now when n is equal to 1, the mu value is 1.7. When n equal to 2, the mu value is 2.8. When n equal to 3, the mu value is 3.8. n equal to 4, it is 4.8. n 5, it is 5.9. Actually it is 2.82, 3.84, 4.89 and 5.92. Like this. We no need to memorize the value. Only thing you have to memorize, when n is 1, 1 point something, n is 2, 2 point something, n is 3, 3 point something, 4, 4 point something, 5, 5 point something. So whenever the value is written like this, we can easily predict the number of unpaired electrons. For example, in the complex of the type Mn Br whole 4 2 minus, the mu is 5.9. What is the shape or hybridization of the central atom? Now mu 5.9 means n will be 5. That means it contains 5 unpaired electrons. Now manganese, the atomic number is 25 and the electronic configuration is argon 3d 5 4s2. Here manganese is in +2 oxidation state, Mn 2+, and that will be argon 3d 5 4s0. One, two, three, four, 5. Now we need 5 unpaired electrons, so we have 5 unpaired electron since it is d5. Now there are 4 bromide ion. So this bromide ion can donate 4 electron pair, and hence we need 4 orbital. So starting from S, we will take all the p orbital and we'll have sp3 hybrid orbital. Hence the shape of the molecule is tetrahedral. Hope you understood all this hybridization, the spin-only magnetic moment, the inner orbital complex and the outer orbital complex. And if you are benefited from my video, then don't forget to share my video, like my video and subscribe my channel so that you get informed whenever a new video is uploaded.